In today's session, we are going to leverage Azure's AutoML capabilities to build a model to help us forecast the demand for our shop. So since we don't have a shop right now, we will download a sample dataset from a very popular data science competition website called Kaggle. And they have many datasets available, and one of them is focused on forecasting demand. So this is our dataset. We can go in there. And we are greeted with a brief description of what the dataset is about. So in this case, it's looking at how many items were sold over 5 years. And if we go to the data tab, we'll see what files we have available. So we have 3 files, and we will focus on train CSV. This one contains the historic data of what items were sold in the store. So we can click download, and this will give us the opportunity to download a zip file with the 3 of them. So we click OK. And now we can see what sort of data is in there in Excel. So here I opened a train CSV, and this is how our data looks like. So each row here represents the date, what store the sales were made in, what item we are considering, and finally the sales, how many items were sold. So we can go on and, for example, filter them by store. So let's say we want to focus on store number 6. So we unselect all and select store number 6. And we want to check item number 3. So again, we deselect all of them and select item number 3. And we go ahead and plot them. So we can insert a line plot. And this is how our sales look like for store 6 and item number 3 over the 5 years that we recorded the data. So we can see that overall our sales are increasing over time, but there's also a very strong seasonal component that may be hard for a human to grasp. But by using machine learning, we can create a model that automatically captures this. So for instance, sales are peak at around spring, but there's always a bounce upwards again every Christmas due to the festivities. So our target for the model is going to predict how many sales are made in a given date, store, and for a given item. So I've already opened my Azure portal on my web browser, and on the homepage we can see all the resources I have available. And I'll assume for the purposes of this video that we have a resource group where we want to create the machine learning studio. So we go to that resource group, and we can directly click on add and search for the machine learning. So we go here, AI plus machine learning, and the first option available is machine learning for Azure. We click on it. And now we are given the opportunity to enter some details. So we have to select some name for our workspace. So let's call it forecast demand shop. Then we select our subscription type. In our case, is pay as you go. And the resource group is already pre-selected for us because we came from there. So now we can review. And also important is that we have to select the workspace edition Enterprise, since this is the only one that currently has the AutoML capabilities built in. So we review and create. We check that our subscription ID is okay, the resource group is also good. The location where these resources are going to be hosted is where we want them to be, in this case UK South, and create. And now the deployment is starting, and this process will take a couple of minutes while everything is prepared in the data center, in Microsoft data centers. Now that our resource is deployed, we can go into it and see the options available. Now that our resource is ready, we are going to go into the machine learning studio. So we just click on the big button, and it will launch it for us in a new tab. So we are in Azure Machine Learning Studio, we are given many options, but today we are going to focus on the AutoML capabilities. So we can click on Start Now. And now we want to start a new automated ML run. So the first thing we are going to do is upload our dataset. So these are the steps we are going to follow. So select dataset. We generate the dataset from the files we've downloaded before. So if we click on Create Dataset, we go to a local file and browse our file system for the data. So it already opened on the folder where my files were, but there could be a possibility that one has to search for them. So we click on Train CSV because this is the historical data we are going to use to train the model. Click Open. And let's add a name for it that is more descriptive than the default ID. We can call it historical sales data. It's a tabular format because it's a CSV, and we can add a brief description if we wanted to, but we won't do it right now. We can click on Next. The advanced settings, the default should be fine. And now we are waiting for Azure to parse our file. So we only have one file, so we don't have to worry about different files having different headers. We don't want to skip any rows, and it's a CSV, so it's comma separated. This was auto-detected by Azure, so it's very convenient for us. We can click on Next, and this is the columns in the file we want to check. So we have a date, store, item, and sales, and we want to keep the 4 of them. So Azure auto-detected for us that the date is actually a date. This is important because we are going to do a forecasting model, and we need to be aware that these are dates and not some arbitrary index, right? And the store and the item were integers that were related to some specific item in the store, and sales is how many units were sold, so that's also an integer. So Azure did everything automatically for us. We can click Next because it's fine. And we are ready to create the dataset. Now that our dataset is loaded into Azure, we can select it and click on Next to configure our AutoML parameters. So first we have to get a name for our experiment. So there's the possibility of running multiple experiments by changing different parameters that will give us different results. So let's give it a unique identifier, so forecasting run 01. And now we have to select the target column. So this is what we want to predict. In this case, this is going to be the sales from a store. And now if we don't have one available, we have to select a compute target. So this is the machine where the models are going to be trained in. So since we don't have one available, we have to create a new one and give it a name. So forecasting PM, and we have to select a size. So there is a trade-off here now. By selecting more powerful virtual machines to run our computations, we get the possibility to train more models and therefore find one that works better for our data. In this case, we are going to go to a slightly smaller machine, but still powerful enough to do what we want to do today. So that's a T4 machine, and we will leave the additional settings at their default values. And it will take a few minutes to gather all the resources to create a new compute target, and we can wait while those are being prepared for us. Now that our compute target is ready, we can select the parameters for our AutoML run. We click on Next. And in today's session, we are going to do a time series forecasting program. because we want, given the observation that we did in the past about our sales, what we are going to sell tomorrow. So for that, we click on time series forecasting. We have to select what column in our data represents the time tags of the sales. We go ahead and click on date. And now we have to select the forecast horizon. So this is how ahead in time we want to make our prediction. This is 1 day, 2 days, 3 days. So today we are going to use just a 1 day forecast horizon, but we could select any other horizon. And we can view the additional configuration settings. These contain information about what metric we want to optimize. So in this case, we want to minimize the difference in between what the model predicts for the sales and what actually happened in the past. So we can choose the normalized root mean squared error. We will select the explain best model option, since this will give us an insight into why the model is making its decisions. And we can go into the additional forecasting settings. So this describes how our data is going to be grouped and what futures we are going to generate from our data in order to make a prediction. So the first one is forecast target lags. So this can be either a single integer or a list of them, and they represent how many steps of time our sales measurement is out of sync with the actual item and store. So in this case, the lag is only 1. And then we have to select the target crawling window size. So this is how many days into the past I'm going to look at in order to make my prediction. So if we set it at the default value, the model will look at any number of days in the past. But here we are going to set it to 7 to minimize the computational cost, because we think, or we make the assumption, that whatever happens later than 7 days into the past doesn't matter for what we are selling today. Finally, we have to select the columns we want to group by. So each entry for our model has to be a completely independent row. So we have to group both by store and by item. Finally, the validation will decide how our data is tested while we are running our models. So in this case, by choosing 5 and k-fold cross-validation, we are breaking our data into 5 sections. So we will be training on 4 sections of the data and use the remaining one to make a prediction and test if our model is correct. And it will do that 5 times for each independent channel. Then you can click save, and everything is configured and ready. Finish. So now our model is getting prepared to run. But since this process, the default value takes 3 hours, but it can potentially take much more if we decide to extend that, we are going to a model that we have already trained to accelerate things for this video. So let's go on to a new one that we already have. And in this case, we run it on experiment 4, and this ran for 6 hours. And we can check it out. Let's click on the run ID. And here we get all sorts of information about the model. So what task type it was, in our case it was forecasting, what metric we were optimizing, what sort of model was finally chosen by the AutoML, and also we get additional information with the outputs of all the training process. So for instance, we can even access all the code that was used to run the AutoML capabilities. So if we wanted to build a script based on what has already been done, we could do that by looking at this code and copying the relevant parts. So, but what we want to do now is directly deploying the best model. And this is super easy with Azure. You just essentially click on deploy the best model. You will be given a few options. So the first thing is what name you want to give to the deployed model. We are going to call it best forecast. We are going to skip the description for today, and now we have the compute type. So we are given two options. AKS stands for Azure Kubernetes Service. And this is a service that once you have deployed it will scale up and down as necessary. So if during the quiet periods it will scale down so that you use less resources and therefore less money. But when there is peak demand on your model, it will create as many resources as needed to cope with that added demand. And then we have ACI, which stands for Azure Container Instances. So this will deploy a single container that will run your model. So if the demand skyrockets, things will go down. But it's meant to be used for testing and development. So we are going to choose that now also because it's cheaper. And we will enable the authentication. So these are the advanced options. We don't need to look at them today. And we can go on ahead and deploy. And now the Azure is preparing our endpoint for the model. So we have to wait for the model to be deployed. And it will tell us once it's ready. Once our model has been deployed, Azure will tell us that it's ready by showing deployment succeeded on the deployed status, and we can go and look at the endpoint that it was generating for us. We are going to look at the best forecast. This is the endpoint that we just generated. And it will provide us with some information about when it was created, what kind of computational resources it's using. In this case, they are very small because this is just for development and testing. And if we go to the Consume tab, we will get the necessary information in order to access this API. So for today, we are going to use Python. And we are going to copy these parameters into our configuration file. So we can simply click here to get a copy of the URL, go to our configuration file, and paste it. And we can also get the primary key. This is the secret that we need in order to be able to authenticate on the API. We can copy that and add it into our configuration file. And now save it, and our configuration file is ready. Now to query, we are going to use Python. So on this website, Microsoft has given us the code to query the model via different programming languages. So we have sample code for C#, for Go, for Java, for Python. We can also access the API using Power BI, so we could integrate it into our reports. Or we could use the raw query endpoint and use something like Postman to do it. So we can go ahead and import some libraries. This will allow us to make the queries and to parse the configuration files. So we can run that code. This will load the secret and the URL from the configuration file. And now we have to remember on how our data was stored in the train file. So we had 4 columns. They were date, store number, item number, and the forecast. So we create a small auxiliary function to help us query faster, and we prepare the data that we want to send to the API. So in this case, it's a list that contains a list with the contents of each query. So if we want to have a single query, we have a single list within the bigger list. So we want to query the model for the 1st of January of 2018, which is the first day after the last data point that we had. And we want to check store 1, item 1, and the API requires us to give a placeholder where we are going to put the final result. So this is why we have not a number here. So we can go ahead and prepare our data, and now we can send it to the API. So This will take a few seconds. And it returns, and it comes back with the JSON, which is a format to output the results from the queries. And we can see that here the forecast for the 1st of January of 2018 was 11 units of item 1 for store 1. Now it won't predict further into the future because our model will depend on the value from the last day. If we want to predict 2 days ahead, we need both today's value, which we don't know yet, and the value from yesterday. So we need to pass today's value, which we don't know yet. So we can get that by using the prediction that we got above. So in this case, that would be 11.65, and this will give some context to the model in order to produce a 2-day ahead prediction. So we passed the data for tomorrow that we predicted above, and then the query for 2 days ahead. We prepare the data, and we can run the query, and in a few seconds we will get back the result for the 2-day ahead prediction. And here's our result. So the first value is tomorrow's prediction, which we made above, and we hard coded here. And the second value is the prediction for the 2nd of January of 2018. And of course, all of this can be automated so that you don't have to manually make a 1-day prediction in order to produce a 2-day prediction. And Azure will do that for you if you automate this. And finally, here's some additional information where you can see what other methods there are to query the endpoint and how the different parameters interact in order to prepare your AutoML model. So now our endpoint is ready, we can query it, and now the only thing left would be to visualize it in a meaningful way that it's good for the end users. So an ideal way of doing this would be to use Power BI because it already has all the connectors that you need, and with minimal effort you can introduce these forecasting capabilities into your reports. And that was the end of this session, and we've seen how we can leverage Azure AutoML capabilities to very easily create and deploy a model that can forecast the future sales for a shop with minimal work and without having any in-depth knowledge of how AutoML works or how to build an API for a model.